acid-base problem, one in acidic media, one in basic media. So you need to be able to do the redox reactions on those. There's nothing on gas law, right? I'm just going to introduce gas law today. So it's really only 2 chapters. You know, we're in week 10 and we've gone over like 4 chapters. It's all right though. It's the basis of what we're doing, and we've covered a lot, and we covered it in depth, which I like. I like the depth portion. Oh, that reminds me. And one thing that, you know, is just kind of funny, well, to me, is that I start taking roll 3 days before the drop day. So, you know, it's not really bad. We're going to keep it though. It's really, you can only miss 3 days without excuses. And what I'd like to emphasize is communication is super important, and that's a pathway you can develop as well. If you're uncomfortable communicating with people like me, just wait till you meet somebody that demands communication but doesn't tell you they demand communication, right? So in your educational process, despite what teachers think, they work for you. They work for you. They may act like you work for them, but that's not really the case. They're servants. And I bring this up at every teacher group I go to, and what you hear is, from the other teachers, is that's not right, that's not how it is. But in reality, that is how it is. A good teacher works for you. It demands a lot out of you, right? But doesn't, not that I'm a good teacher, I didn't mean it that way, but I meant, I model myself after people I thought were good teachers. And mostly those were in books and they're 2-dimensional. All right, so are we ready to do some chemistry? No questions at all. We all understand everything about the test.
No.
Well, what would we like clarification upon?
Everybody's like, what?
Can you go over one that's going to be on the test? I'm just kidding. Number 2? No.
Number 2. I don't.
I don't have it on.
But basically, what happened is, with Brittany's help, we posted. I am not posting the answers to the test questions. I'm posting videos of the answers of me going through the problem. So I feel like that way at least you're working and not just copying.
Yeah.
You have to sit through more of me, ha 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 ha.
That's what I was meaning. Can you go over one of those that you did on your recording?
What?
Can you go over one of the ones you did on the recording?
Sure. I don't see why not. I can use a few minutes because we're just going to introduce gases today anyway. So a little bit of this would be all right. We can do it right now if you'd like. So every time I do a problem, this is the other thing. Every time I do a problem, I don't necessarily do it the same way or say the same things, right? It just whatever comes in, it's like a flow of consciousness. It's not a scripted deal. You're going to see a lot of scripted deals, and it makes it seem like people solve problems like, oh, this is just how you do it. That's not how anyone solves a problem. The other day I was trying to solve a problem on Zoom, and I couldn't do it because I hadn't practiced first, but I got caught up, and then it took me 20 minutes to unscramble myself and get the answer. So keep that in mind when you're watching these people go through videos. They set it up. They practiced it. They have a script they're following. They're actors. No one solves a problem like that. What you see when you see me is a real person solving a real problem. It's not someone, anyway, that doesn't matter.
It's real time.
It's real time. This is behind the scenes, Actors Guild. Right. So what's the problem, Maria?
Do you want to see this? It's number 2 or number 3?
Who has good writing?
Not me.
Not me.
Nate does?
Oh, this one. Yeah, Nate has real good writing. So again, here's how I look at things. Before I actually solve the problem, so this is problem 2, I'm going to look at 3 atmospheres. So what is this? ATM, that's a pressure. So already I'm just going to label that pressure. I don't know anything about the problem, but I know the first number I see has units, atmospheres, pressure. So that's pressure. Then I have 250 milliliters. And I know that's a volume, right? Milliliters is always representative of volume, so we went through that. And then 800 milliliters. So even without knowing anything, I know that's a second volume. And then 450, oh, but I look at this one, absorbs 450. Is that kilojoules or just joules? Just joules. So that's a plus. Absorb is plus, means heat's coming into the system from the surroundings. All right, and then I look at the next number, and that's releases 150 joules. Well, it can't do both in one process. So that means I have another process, 2. So I'll call that 2, I'll call this 1. These are tied to 1 and 2, and even though I don't know that to be a fact yet, it's going to become obvious because now I have another volume of 125 mils, and then I have, so that's a volume, and then 5 atmospheres, that's a pressure. All right, now I can go back in and fill in some missing data. So what happens here? So these are my numbers, and then it says a piston filled with gas. So I have a piston, and it's filled with a gas, and I would assume the gas is in here. And then it says expands. So that means it goes from 250 to 800. All right, so that means this is volume initial, this is volume final. So we got an expansion going from 250 to 800, and then what else do we have? Okay, so that's it for the first one. When I see, does it ask me anything? What is the net overall change in energy? So delta E, change in energy. Now I'm going to look on my paper because I didn't have time to remember what the formulas are. I didn't memorize them. And I look in the back and I'm like, well, there's KE, that's half mv squared. That doesn't make any sense there. I've got E equals Q plus W. Ooh. I have W equals minus P delta V. But if I say E equals Q plus, Q plus a minus P delta V, I have a delta E, right? So you have to make sure that this is Q plus W, but you should recognize this, right? These are the units we're looking for. Pressure and volume, we have pressure and volume, we have a change in volume, delta V. So for the first process, all I'm gonna do is do delta E, and I'm gonna call it E1, right? And I'm gonna say Q plus P delta V. Then my Q is plus, so 450 joules. I'm just going to fill it in now. My pressure is 3 atmospheres. So that's minus P delta V, minus 3 atmospheres, right? Times the change in volume, final minus initial. So 800 milliliters minus 250 milliliters. All right, except for, I'm already feeling something weird here. This is going to have to be in liters. So I'm going to make that change right away. And if you haven't noticed, dividing by 1,000 just moves the decimal 3 places. So there we go. So that becomes this, and this becomes that. No, this 800 mils becomes 0.800 liters. This 250 mils becomes 0.250 liters. So now we have everything we need except for, what are our units now? Our units are atmosphere liters, and we're trying to add to joules. You can't do that. So we need a conversion. And that's back here on the conversion sheet. There's a conversion that says, conversion factors and constants, 101.3 joule liter atmospheres. And let's make that A-worthy. Right, and so now our liter atmospheres are going to cancel out, and we're left in joules, and now we can add these 2 units. So that's it for the first process, but there's this whole other set of numbers. So there must be another process. And what does it say? It says, the piston is compressed to 125 milliliters. But from what? Well, the last time we looked, it was at 800. Right? So now we're just going to take the piston and go from 800 this way. So 800 is the initial, and 125 is the final. All right, and so now we have everything we need to do delta E process 2. So, oh, what about this? Did we look at that? What does it say? It says 150 joules releases 150 joules. So if you release energy, that's energy going from the system to the surroundings. So that's the exothermic process. So Q there is negative. So remember, this is Q, and this is constant, right? So this is really what? Enthalpy. So Q minus P delta V. And you could leave that out, right? So Q is minus 150 joules minus pressure, 5 atmospheres, times delta V. Oops. Delta V is, now we've got the other reverse process, right? This is the initial volume, this is the final volume. I'm gonna make that change right away. So final is 0.125 liters minus 0.800 liters. And then I'm gonna have to use my constant again so that we get into joules so that we can add this together. So that's E1, E2, and then to finish off, I just add E1 plus delta E2. So we just add those energies. So each energy process happens individually, done.
Real quick, on the conversion, the 1.1.3 joules to, is that 1 ATM liters? Or what's the notion?
Yeah, so if you wanted to break this down, you could say this is 101.3 joules times 1 over liters times 1 over atmospheres. So basically, per liter atmosphere is a joule, and it turns out that that's the work unit, right? That's how to cancel out the change in pressure and the change, or the pressure and the change in volume.
So even though it's written ATM liters, it's one. It's implied that's a 1 for the actual math. Meaning it's straight multiplied by 1.
In order, the conversion to joules atmosphere per atmosphere liter. Yeah, this is like 1 over atmosphere.
Got it.
So we're just canceling out this unit, and the unit that makes it okay, the conversion, is 101.3.
Okay, that makes sense.
For atmospheres. There are other ones for the other units. Okay. Is that helpful?
Yes.
Very helpful.
So we subtract the energies after,
We add the energies.
or add them? Oh, my bad.
Right, so 2 processes, we want the total energy change. The total energy is going to change is going to be the energy 1 plus energy 2. And if you notice that we do that for all our different processes, if we have several different heat exchanges, we add them together. And when we do our conversion from the Hess's law stuff, not Tesla, because everybody wants Tesla, nobody wants to mess with Tesla. Anything else you want to do before?
So then to properly just submit this question, you would just give these solutions to each equation, and that would just finish the math and.
Right, so yeah, you have to finish the math
Yeah.
on your own,
Yeah.
but this would be an answer in joules, and this would be an answer in joules.
And the question was initially asking for what?
Yeah, question is delta E for system.
Okay.
Yeah, I didn't answer the question. Because to me, it's always, I don't even need the question, right? Because it's gonna be what everything adds up to.
Yeah.
Like, if I have these numbers, what am I looking for? Well, I have my units, so I'm gonna plug them into my equation. My equation's gonna give me delta E. So I obviously, if there's no delta E, that's what I'm looking for. I have a Q, right? So I'm not looking for Q. I have a pressure and I have a volume, so I'm not looking for those. That's kind of how I approach these things, but I do a lot of them. So if one of the things I do when I'm studying is I go find a worksheet that has whatever subject I'm looking at, right? And they're everywhere. You just type in delta E worksheet, and then there'll be a plethora of them, from high school level to college level to, you know, UCLA sometimes has them, and you're like, wow, they really are convoluted. They really make this into a mystery. But some people make it into a real simple thing. Yeah.
Are you done with this one?
I believe so, yeah.
Can you do number 8, problem B?
Before you erase that, Mr. Richard. You don't mind?
I don't mind, but you got to do these things on the fly, bud.
Yeah.
I mean, we're holding up now.
You're awesome.
Now we were rolling, and now we've got to wait for you to take the film. Just kidding.
It's my class.
It's your class, dude. Take the picture. We'll stop. I mean, I don't know how many times I can do these problems, but probably forever. I mean, I've already done them for three times, but not this year. This year I've only done them like a few times. That's why I'm making the videos, not so that you'll watch them, but just so that they're there for future. And then I can just release them. So what I really want to do is just start finding teachers' classes and doing all their homework and putting it online. Because really, I'm so tired of hearing about how students shouldn't use their resources. Because to me, it's all about using your resources. Why would you reinvent the wheel, right? If the wheel already exists, take the wheel, use it to make something like a car. Don't go backwards and go, well, you know, a wheel should. All right. What problem? 8B. That's the. Yeah. So this is the net ionic equation for 8B, ammonia and nitric acid. That was fun. Didn't last long. NH3 plus HNO3. And this is going to make what? Water? NH4 OH. What am I making? Yeah. NH4 OH plus what? Oh boy.
Yeah, it's most
Boy. Oh, so I'm not going to do that. I'm not going to make OH.
That's fun finishing that.
I'm going to do this. Oh, that's NH4. So then. Yeah. Right, that works. Yeah.
Yeah, how would you know to, if not using the normal rules to just go back to 120 stuff? How would?
Well, the other way you could do it is you could just say it was a synthesis, and you could do this.
Which number was this one?
8B.
Thank you.
You could do this. Right, and just say this is aqueous. But one of the ways you could do this is strong acid, weak base. So a strong acid is going to donate its H plus, right? Because nitric acid in water is H plus plus NO3 minus, right? And now we have NH3 aqueous, and then it's going to be in equilibrium with NH4 plus, and that's going to leave this in the NO3 minus, and then we're just going to have NH3 plus, oops, aqueous, 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 aqueous. So this is going to be the total. So that's the total ionic equation. And then this is going to be the net ionic. But I wouldn't put this one on the test, because it is a little more complex. But basically, a strong acid completely dissociates protonating a weak base. So whenever, I guess I need the NH3 there. That didn't make sense to anybody. So you have a weak base, which means it doesn't really want to accept, except for the fact that you have a strong acid, which wants to donate real bad. So it kind of overpowers it. Every time we shift a little bit, that opens up a new concentration. And that's what's happening. It's like when we work in basic media, we add more base, freeing up more OH, eating up all the acid. Well, in this case, we wouldn't eat up all the acid if it wasn't a strong acid. But it's a strong acid, so we eat it all up.
So secondary on top of that, consulting Google, it says the other side is NH4 or NO3 plus H2O. Would that be?
Well, I mean,
so if you
do it, so here's what else can happen,
yeah.
right? Water is in H2O, and H plus. All hail the mighty Google.
Yeah.
Anyway, is always in this equilibrium. So you can drive that and have this meet with that, but that's not. I mean, it's not evident, self-evident. So
you wouldn't. Okay.
But I wouldn't mark it wrong.
Yeah.
It would just be another way of doing it.
Got it.
So you could, but what we're really looking at is the interaction between these two and not the water.
And not what it makes. So.
Right. I hope that was helpful, Nate. All right.
You want another? I'm just kidding.
Yeah, we can do one more if you want.
Anybody else have one?
Should we try an acid base on the board?
I have a question about number 9. Just
Number 9. Number 9.
That'd be great.
9.
Number 9. Say you want a revolution. We all want to change the world. All right. Well, if you go carrying pictures of Chairman Mao, you're going to make it anyhow. Paul McCartney. Oh yeah, number 9. Yeah, okay. There's a nice video on this that I just did. So 3.5 molar, and I'm just going to write all these down. Well, no, let's just do them one at a time. HNO3, because I changed my mind, because this is how. So I'm going to solve it differently than I normally do, right? Why not? So strong acid, nitric acid is a strong acid. You should know that, period. There's 6 strong acids, at least no nitric, because it's the one all the chemistry teachers use. Because I'm not sure they know how to break up the other ones. HNO3. So HNO3 in water, right? And it's aqueous, that's what makes it an acid, it's in water, otherwise it's hydrogen nitrate. So hydrogen, nitric acid in water breaks up into H plus NO3 minus, which is why it's really good to memorize the polyatomic ions. Because now, whenever you see NO3, whenever I see NO3, I don't think, oh, what is that? I say, oh, that's nitrate. All nitrates are very good. Thank you, Brittany. Checks in the mail. All right, so aqueous here. So how many ions is that?
1.
That's 1, and that's
1.
So how many total?
2.
2. So whatever concentration we have of HNO3, when it splits up into ions, it's 2 times that. It's 3.5 molar in H plus 3.5 molar in NO3 minus. Yeah? So that would be 7.0 molar. Yeah? You follow? Total ion concentration, 7 molar. All right. And whenever we have ions in solution, it's called an electrolyte. Whenever there's complete dissociation, that's what I prefer to call my astrology 2.0, which is dissociation, not associated with people. All right, so complete dissociation is strong electrolyte. All right, so that's the first one. And then 4.0 molar sucrose. Does anyone know what sucrose is?
Sugar.
Well, yeah, and then I was just hoping some of the bio majors, instead it's the construction management guy that knows more biology than the biologist.
I just know
Ooh,
those-
I'm just kidding. Them's fighting words. Just kidding. Anyway, H22O11. Right. So, what we know about this is a hydrocarbon. Hydrocarbons are not ionic, and if we're not ionic, what we have is a bunch of these stringy molecules tied to each other, but not bonded to each other. The bonds are between the C12, the H, and the O. So those are bonded together, but the molecules are held together by intermolecular forces. So when we solubilize those, or we dissolve them in a solvent, the solute in a solvent, then we are breaking intermolecular forces, not bonds. And if you don't break bonds, you don't have ions. You just have molecules floating around in solution. So this is a non-electrolyte, which means it's non-conductive. So we just found, covalent compounds are not conductive in general. But water is. Why? Because water self-ionizes. Water comes apart. Our covalent compounds are not conductive, and they'll put that asterisk there. And then, so what does that mean? That's what that means. So this is going to be it's the only covalent compound. Covalent compounds, remember, are non-metals bonded to non-metals, unless they're polyatomic ions. But compounds like sucrose are non-conductive. So the next one is 3.0 molar sodium chloride. All right, so sodium chloride is completely soluble, right? It goes only one way. Na plus Cl minus, and this is going to be aqueous, right? So we have two ions in solution. This is aqueous because it says 3 molar, which is moles per liter of solution, right? Whenever I see this M, it's just, I don't even look at it as that. I look at it as this, always, moles per liter. It's just represented by this big M. But if I have 3.0 moles per liter, I always have 1 liter over 3.0 moles, or 3.0 moles over 1 liter. But I can use that either way. If I have a number of moles, I can cancel it out. If I have a number of liters, I can cancel that out and get the number of moles. And that's all solution chemistry is I have this amount of moles, how much volume do I have? Well, if I have this many moles of A, how many moles of B do I have? Well, what's the ratio of the chemical equation? All right, so we break this up. How many ions are there?
2.
2. So total ionic concentration is 2 times 3.0 molar, or 6 molar. All right, next is 6 molar acetic acid. CH3, COO minus plus H. So that's that. That's acetic acid. Turns out acetic acid, well, let's do it this way. Short here, long this way. Only partially dissociates into H plus CH3 COO minus. And why? Because it's a weak acid. And we know that because we know this, we recognize the 6 strong acids, and acetic acid isn't one of them. So we have to be either recognize the 6 strong acids, memorize the 6 strong acids, either way. So let's make this a real 6. And I still can't make a real 6. So HC, boy, that's not so good either. And while you're writing it down, I can write it down. So what happens here? Since it doesn't come completely apart, we're going to say it's much, much less than 6 molar.
Why?
Because when it comes apart, it doesn't come completely apart. So it's not really giving us 3 molar this and 3 molar this, because it's only partially dissociated in water, which makes it weak, which is when we were doing our solubility and conductivity lab, that this didn't give you a strong electrolyte, it's a weak electrolyte, because it has less ions in solution. Weak electrolyte. Weak conductivity. So I'm not the only one with weak conduct. All right, so let's see, what's next? So 2 molar, and this one is, oh, it is fixed. So 2 molar H3 PO4. No, oops, not H3. That would be fun. That would have been a better, that'll be a better one. And let's do it again. So here we go. 2.0 molar NH4 3PO4 aqueous breaks into, what does it break into? So it breaks up into NH4, but how many times? 3. Aqueous. Which is how many ions?
4.
4 ions. So 2.0 molar times 4 ions is 8.0 molar. Does everybody see where that's coming from?
Mm-hmm.
So each one of these NH4 is 2 molars. So that's 1, 2, 3, and then the PO4 is also 2 molar. So 2, 4, 6, 8 molar in ions, right? Not in ammonium phosphate, but in ammonium ions and phosphate ions dissolved in solution. So it's going to be a strong conductor. Now, what do we have? We have 6 here, 7 there, 8 here, and then what else do we have?
I have a question.
Okay.
Is PO, I thought, will PO4 be 3 minus?
Yes.
So would it be more than 8?
No. Because this is just 1 ion.
Okay. But
Yeah. Remember, the charge isn't how many ions there are, the coefficient. And if you're having a hard time with coefficients, you can put a 1 here, right? You could always say this is NH4 3 PO4 1, right? That would be the crossover method. And that way you could remember if you needed to. And so the last one, we're going to bring all the way back over here. I'm going to go 3.0 molar calcium hydroxide. And that breaks up into calcium 2 plus aqueous plus 2 hydroxides aqueous. And so that's 3 times 3, or 9.0 molar. So then we're just going to rank them: 9.0, 8.0, 7.0, 6.0, less than 6, and then sucrose, the non-electrolyte. So if we wanted to do that, we do. So this is 3 times 3 molar, because there are 3 ions. So 9.0 molar in ions. And so this would be 1, and then 2, and 3, and 4, and 5, and 6. You okay with that, Nate? Okay. Of course, now I have to change the problem.
Hmm?
Maybe not. It's getting a little late in the game for me to change the problems.
So, really has nothing to do with the charges? What's that problem?
Not really. Not really. It has to do with ions in solution. You could say, right, something that has an overwhelming number of positive charges might be more conductive if they were tied. But since we have the solution is filled with electrolytes, it'd be all right. Okay, should we get going on gases? I do have one question. If I were to give you a redox equation right now, would you be able to solve it in acid and basic medium?
Go ahead and do that one.
Yeah,
Go ahead and do it.
that's what I was wanting.
So someone, let's see, weren't there some practice redox equations in the
Yeah, they're
way back?
They're in the can.
They're in the Canvas,
They're not.
right? I thought so.
What really threw me was one on the nice quiz, last nice quiz.
Yeah.
Number 6 from the nice quiz, doing it in basic solution. I was confused as all on that one.
Yeah, I'll do one in basic. I can do that one, I guess. Didn't I do that one already in class? Didn't I do both of those in class? Yeah, no? Okay, half people say yes, the other half were sleeping or just so mad they weren't even listening.
If you did, I didn't catch it, but let's see a fresh one, just so I have
Just see if,
another.
that's what I was gonna do. I was gonna do a
Exactly.
fresh one.
Yeah, so I have another.
One we
piece
haven't
to
seen,
base
so you
on
have,
top of.
yeah,
Do a fresh one.
yes, fresh.
She doesn't want to see the MnO4.
Nobody wants to see the permanganate.
That's-
Not even me. I don't want to see the permanganate ever again.
Maybe.
Once you guys spit it out on the test, that
6 times.
James.
6 times I can't see it. That's what I understand. Maybe not.
Do we have that quiz? Does somebody have that quiz? So
I have it.
oh no, I'm doing a fresh one.
Yeah, fresh one.
Okay.
Please, fresh one.
Did anyone print out the practice test, practice questions?
Yeah,
Yeah, that was what I.
you have it all right here. Choose
The
one.
practice redox thing?
Oh, yeah, I did. Yeah.
Wow.
Oh, great.
Yeah.
They're not done, but
Yeah,
they're.
they're not
Well,
done.
they don't have to be done.
Oh,
Wow.
We have a ton of stuff.
give me a minute. I gotta find them.
You guys got to get some sleep.
Seriously.
Yeah,
What?
no.
You sleep when you're dead. That's what I always say.
I put them in
For the next 2 days, there will be no.
You don't have to have done it.
feedback
I just
exam.
wanted to.
I just won't.
Okay.
Or during.
Wait, they're right here, right here, right here. Come back. Come back.
Oh, here we go.
Okay.
That was very nice falsetto there, babe.
Complete molecular. Okay. Is it this?
There are these right here.
Now, here we
Yeah.
go.
Oh, you have a whole bunch of them.
Yeah, there's a lot.
I printed a bunch.
Okay. Is there one more page?
It's all this is there.
1, 2, this is the one
I
we
made
want.
a copy of the same.
All right.
I'm gonna need that back.
Here's one that we haven't done. I like this one. Well, I like any of them I haven't seen before, right? TE, but it's only T, it's not T. Plus N2O4. Now, this is the kind of place where I can get messed up, right? Because I haven't looked at this one at all. So,
Same.
but now that I've seen this worksheet, maybe I'll take one of them off here. Okay. And should we do this in basic? So in order to do basic redox, we have to do acidic redox first. All right. So the first step is always to identify the half reactions. So we have TeO3 and then Te. All right. So this Te is 0 because it's elemental. This Te is complexed with technetium is complex. Is it technetium? Te? Tellurium. Complex with oxygen and -6, so -2, -2, -2 for a -6 total. But you need 2 minus at the end, so then that's 4 plus. So this is tellurium 4 plus, and it goes to tellurium 0. So how many electrons do I have to add to get from 4 plus to 0?
4.
4. 4E minus, right? Because I'm going to go from -2 to -1 to 0, and that's it. What?
Wait, no.
Oh,
we-
wait,
that's
I
two,
screwed
right?
that up. I'm going to go from 4 plus to 3 plus to 2 plus to 1 plus to 0. There we go. 4 times 4 electrons to balance it out. So I'm going to get rid of this. So that's my first half reaction. I'm going to put the other half reaction here. No, I can't do it that way. N2O4, but I could do it in a different color. That would be fun. And make my day. So, good. Uh-oh. Just wanted to make sure it wasn't a cannon. O4, and then we go to NO3 minus. Now I remember something about doing nitrates on the board, and I know this is 5 plus. But let's do it anyway. 2, 4, each electron from oxygen, each oxidation number is 2, 4, 6. And I need a -1 at the end. So I'm going to add 5. There's 1 nitrogen, so that's +5. Here we have -2, -2, -2, -2 for a -8. There is no charge, so 0, which means I have to make this +8. But +8 over 2 nitrogens is +4. So I go from +4 to +5. So I lose an electron, so it goes on this side, on the product side, 1E. There's something weird going on here already, I can tell. What's weird? What's the first thing that's weird? I mean, what's besides, what's obvious that's not working out already?
Balancing?
The oxygen, yeah, I have to balance the hydrogen and the oxygen first before you get to the electrons. And then there's the elements.
Well, yeah, don't I have to balance the elements first?
Yeah.
Yeah.
That's up to-
So there's a 2 here. Right, and this is, remember, don't leave, this is +8. This is +8 divided by 2, so this is 4 plus. All right, so that works, right? +4 twice, so this is 2E, right? And then the next thing is, wow, I got to get my waters, right? So I have 4 oxygens on this side, well, and I have 6 oxygens on that side. So I need 2 waters on this side. Yes? You guys see that? All right. So now I have 4 hydrogens that I need to worry about.
Wait, can you repeat the 2 waters again? Like,
Okay, so I have 6 oxygens on this side, right? 2 times 3, 6 O's. On this side, I just have 4 O's.
oh,
So I have to I have more oxygens on this side, so now I have to add oxygens as water. And I need to add 2 of them to balance my O's. Now I have 6 O's on this side and 6 O's on this side.
thank you.
Yeah, okay. And then I need to balance my H's, so I have 4 H plus here. All right, now I'm at my tellurium. Is it tellurium? TE?
Yeah, we'll go with that.
Yes.
Yes, all right. Thank you, George. So I have 3 oxygens on this side, no oxygens on that side, so I'm gonna add 3 waters. Oops, that would have been even a better way to do it, but I didn't do it that way. Okay, and now I have, I need to add my hydrogens, so I have 6 hydrogens. Okay? And now I'm gonna add my 2 equations together. So I'm gonna start with my, oh, wait. No, I'm not, because why?
You have to balance the
I have to balance electrons. On this one I have 2 electrons, on this one I have 4 electrons.
Why did you put 2 on that? Was the 2 in front of the NO? 3?
Yeah, because each time I go from N4 plus to N5 plus, I lose an electron.
Okay.
If I do it twice, I lose 2 electrons.
Okay.
And then, so I need 4 electrons, so I have to multiply this whole thing by 2. And I just do that. Hopefully I do that correctly. Okay, so now I've got 2 N2O4 plus TeO3, and then my E's cancel out, right? 4 here, 4 there. I have 3 waters on this side and 4 waters on that side, which leaves 1 water. And now I'm going to go to my other side, right? So I've taken care of everything but the hydrogens. Oops. Yeah, 6 hydrogens here, 8 hydrogens there, which leaves 2 hydrogens. Yes? Everybody see that?
Yeah.
Okay. And then we go to TE. Don't forget to sign the roll sheet. And plus 4 NO3 minus and 2H plus, right? So I've got 2 hydrogens on this side, 2 hydrogens on that side. I've got 8, 11, 12 oxygens. 4 times 3 is 12. 4 nitrogens, 4 nitrogens, and 1 tellurium on each side. So that's acidic. But we need basic, because that's the name of the game. If you can do it, it's no need to separate acidic if you can't. I mean, no, but it doesn't show anything if you can only go to here. It only shows that there's 1 more step. So what do we do next? We want it to be basic. How do we make things basic? We add an OH. So 2 OHs to balance this. Right? Is that what we do?
Both sides.
To both.
To both sides. Oh yeah, that's a good idea. It's like adding 1, right? No, that's, yeah. 2 OH minus. All right, so now we put these 2 together and we have 2 H2O. And now we just add it up, right? H2Os cancel, so we have 1 H2O. And our overall problem then becomes N2, or balanced equation, I should say. That's it, right? That's all you have to do. Ooh, those are fun. You do those all day. And those weren't on the practice test, but there's definitely going to be one of those on the exam.
Just one or multiple?
No, just one.
Would ask for basics so we know our acidic and then just finish.
Right, and if you can only get to the acidic part, or if you can only balance the electrons, do the part that you can do, don't just leave it blank. And if you need to, draw a picture.
Drop it. I
Do
forgot the
something.
last exam.
Let me know you were here. Anything else?
Just a quick question. There wasn't any on practice, but will there be questions on how many ions are formed when dissolved in water?
Yeah.
Okay.
There'll be the practice test about, it will probably be ammonium phosphate. It'll probably be just like that problem. No, I won't. I'm going to change. But yeah, just like that problem with a different compound. It was just like that, but since you asked about it, I have to change it. But it's going to be a very similar problem, right? You're going to break it up into its ionic components. I'm going to give you a gram amount, and you're going to calculate what the molarity is. All right. Like I may just change it from 0.216 to 612. Well, something has to be guaranteed on this test. And then there's the iron problem that was on the first test. That's also going to be there because I want you to be able to do that as well. So there's a couple of gimmies. Oh, and by popular demand, I added a true-false section.
Yay.
And if you know me, you know I have a really hard time doing false things. I'm pretty much true blue. Anyway, so if you're hesitant,
You have a high chance of.
yeah, if you're gonna guess
Pick
true.
A, not B.
Yeah. I also have that problem when I do multiple choice, right? It's almost always A.